So hello my dear students, now we are going to start with eigenvalues and eigenvectors, and the first definition that we are going to see is of eigenvalue and eigenvectors only. So let us try to see the definition in a little bit detailed manner. So if we have a vector space of dimension n and a linear map from V to V, then we can talk about the concept of eigenvalues and eigenvectors. So first of all, let us think of eigenvectors, because eigenvectors are basically the vectors that gives you the eigenvalues. Okay, so we are interested in finding such vectors in V. Now see, since T is a map from V to V, vector space V to V, right? So we will find images of the elements of the vector space V, but we are interested in some special images in the sense, if I find T of some, let me say V1, then can I get multiple of V1 again? That is what we will think of, because T of V1 is again going to be some vector in V, right? But I want this vector to be something special. And what is the speciality of that vector? I want that vector to come out to be somewhat multiple of V1, isn't it? So I am interested in that type of vectors. So if it comes out to be multiple of V1, then that vector will be said as the eigenvector, and your corresponding eigenvalue will be alpha. This is the meaning, right? So in other words, if I take V2 now, so if I find image of V2 under T, and suppose my image of that vector comes out to be multiple of V2 again, then that vector will be called as eigenvector, and whatever multiple we get, that value will be called as an eigenvalue. I hope you are getting my point. Obviously we are going to discuss it with the help of a beautiful example. Okay, so that is what it is said in the definition. So alpha belonging to R is said to be an eigenvalue of T if we are able to find a non-zero vector such that T of V is equal to alpha V, and here this V is said to be an eigenvector corresponding to eigenvalue alpha. Okay, so we are interested in finding some special vectors that will satisfy this property. It means if you find image of that vector, you should get multiple of that vector back, and whatever multiple we are getting, that multiple is called as eigenvalue, and that vector is called as what? The eigenvector. And the eigenvector and eigenvalue are related to each other. I mean, okay, if you talk about eigenvector, then definitely you are going to have some eigenvalue, and if you are talking about eigenvalue, then definitely you are going to have an eigenvector corresponding to it. So just remember, these eigenvectors may not be unique. You will understand why. Okay, but eigenvalues are unique whenever you talk about some linear transformation. So over here we are finding eigenvalues and eigenvector of a linear transformation. So whenever you talk about a linear transformation, definitely it is going to have eigenvalues and eigenvectors. So the eigenvalues are unique, means if I tell the students to find the eigenvalues of a linear transformation, everyone will get the same eigenvalues. But suppose the eigenvalues comes out to be alpha 1, alpha 2 and alpha 3, then the next question I will ask, find out the eigenvector corresponding to each eigenvalue. Means corresponding to eigenvalue alpha 1, there will be some collection of eigenvectors. Corresponding to alpha 2, there will be some collection of eigenvectors. Corresponding to alpha 3, again you will have some collection. So whatever eigenvectors you are going to get corresponding to alpha 1, you all students may get different eigenvectors. Similarly, corresponding to alpha 2 as well, you may get different eigenvectors, but whatever eigenvectors you get, they are going to satisfy some special property in common that we are going to see later on. Now let us go for one example of eigenvalue and eigenvector. So example, if T from R2 to R2 is a linear transformation given by T of xy is equal to 2x comma y, let us think of some special vectors such that t of that vector v1 v2 should be equal to some scalar multiple of again v1 v2. That is what we want, right? So we will find t of some vector and we should get the multiple of that vector again, right? I hope you are getting my point. So if I talk about t of 1 0, what will be t of 1 0? It is going to be 2 0, and 2 0 is nothing but what? Can I write it as a multiple of 1 0? Obviously yes. Which multiple of 1 0? I can write it as second multiple of 1 0. It means that this 1 0 is an eigenvector corresponding to eigenvalue 2. So our 1 0 is our special vector satisfying the property that we want. Can we think of some other vector? Yes, if I think of 2 0 will or 3 0, let me say, if I talk about 3 0, will this vector again satisfy the property that we want? So what will be the image of this vector under this t? So the image of this vector will come out to be, first of all let me erase this. So we are talking about t of 3 0. So what will be image of this vector? So it will be 6 0, right? So it is 6 0. So can I write this vector as a multiple of 3 0 again? That is what you should think of, right? Because we are starting with 3 0, and the question is and the answer is yes. So if I take 2 outside, you will get 3 0 back, isn't it beautiful? So you got the same eigenvalue. Are you able to note it? So this is our eigenvalue, right? But again the eigenvector is little bit different. This is your eigenvector, right? Now let us think of some another vector. So I will think of t of, let me say, half 0. So what will be my t of half 0? It will be, I guess, 1 comma 0. So can I write it as a multiple of again this vector half 0? That is what you should think of. Definitely yes. How can we write it? Twice inside the bracket half 0. Is that okay? So again this is our eigenvector and this is our eigenvalue. Is that okay? So can you see we are getting unique eigenvalue in each case, but the eigenvector is different. Okay, now let us think of, but if you observe properly, this eigenvector is satisfying a special property. Can you guess what is a special property? The property is I am taking these vectors to be multiple of 1 0. So here I started with 1 0, I have taken multiple of that 3 0, again I have taken the multiple of that only, that is half 0. Okay, just keep it in mind. Now let us think about some another vector, not multiple of 1 0 actually, some another one. So let me think about some 0 1. Okay, so if I talk about t of 0 1, so what will be my t of 0 1? My t of 0 1 will be, it is going to be 0 comma 1. So that was straightforward and simple, and which is a multiple of 0 1 actually, because I can write it as 1 times 0 1. So this is eigenvector again, isn't it? And what is the eigenvalue? The eigenvalue is this one, right? That is 1. Okay, now the next question is, let me think of 0 3. Similar idea, I have taken multiple of that. So 0 3 will be the 0 3 1, and which is again multiple of 0 3 back, because I can write it as 1 multiplied by 0 3. So this is your eigenvector and this is your eigenvalue. Now again focus on the eigenvectors that we are getting. So they are all multiples of this 0 1, but eigenvalue is staying unique. Now the next question comes, whenever you are having a linear transformation, how many eigenvalues it will have and how many eigenvectors it will have. So that part we are going to see later on.